post-farm gate, which is an important part of CL's activities. So I think this is a joint presentation. Matthew Sharman, who is Head of Food Science here at Ferrer, and Charlotte Maddox, who many of you will know, who is Agriculture Manager at Tesco, one of our industry members, obviously, and who leads on agriculture and R&D. So, Matthew, over to you.
Thanks, Nick. So this morning we've heard lots about species, we've heard lots about informatics, lots about the need for data, and I think the species I want to focus on now is a cross-cutting species called the consumer. So I don't have a particular interest in whether it's a pig, a sheep, whatever else. I think about the consumer when I'm thinking about my research, but also that should be the focus to me of CL's research, because unless we produce products that the consumer wants to buy, then that's not a good idea for the industry. So what are we going to do within CL in terms of investment? Well, we're going to provide access to the latest measurement sciences. And those measurement sciences will cover both chemistry and microbiology. And as I said already, it's about consumer focus. And what we want to do there really is to provide robust data sets, data which industry can trust and make business decisions on. And if you have robust data, your business decisions will be robust, and hopefully that will give you business superiority, a business advantage going forward. But actually, this is really a cross-cutting technology. Measurement sciences aren't just about what's for the consumer, it's about what can be applied upstream as well. And I'll give a few examples in just a minute. This is one of the earlier slides as well, which we presented as part of the bid for CL. And you'll see in the middle, we have CL as the hub, and we have lots of interested parties from the retailers, from the food processors, the farmers, etc., etc. And actually, when we started thinking about it from the consumer perspective, we were really focusing on food safety. Of course, I mean, that's a given, really. If you're selling to someone who wants to eat it, it has to be safe to eat. But measurement sciences are so much more than that. We can also use them to look at product quality. Not only about measuring what product quality is now, but how can we use measurements to predict product quality going forward. And again, so if you think about the cross-sector, the cross-cutting capability of measuring things, we can then think about the nutritional aspects of the work of CL. What are we feeding the animals with, and what is the final product in terms of the consumer? But also many other applications, animal health, stress indicators are often important. Can we use new measurement sciences to measure animal stress and how that affects product quality? If I focus a bit more on and actually sort of the food and feed integrity side of things, by integrity I mean it's safe, it's of the right quality, it's of the right authenticity. There are a lot of external drivers affecting the industry. Economics, the economics of supply of feed materials, of food ingredients. External events, climatic change, things like emerging mycotoxins and how they affect the animals and how they affect the growth rates. But also the processes. What processes are used in terms of taking an animal into a final product? So to address some of these issues, one of the investments of CL is something called high-resolution mass spectrometry. I'm not going to test you today on what that actually means. I'll save that one for later. But actually what we're talking about here is much more holistic assessments of products. So the ability to answer many questions simultaneously. And as David has already said, informatics will be key to some of those things. At the moment, a lot of the technologies we're using, we can actually measure much more than what we do with that data. So we collect the data and we don't actually use it effectively. Within CL, by combining the measurement scientists with informatics, we'll answer many more questions. But also, it's not just about doing more measurements, it's doing them in the right place. If we can conduct some of these measurements in real time, you can make decisions which affect processes there and then. Can you make decisions just as the animals arrive on site, for example? But also the new technology will be able to differentiate between very similar chemicals. In the past, this has been quite a challenge, so isomeric compounds often have different behaviours. This technology will allow this type of decision to be made. But also probably one of the most exciting things for me is that the new technology allows what I call both bulk and surface measurements. To me, a bulk measurement is taking a piece of chicken, taking a piece of beef, extracting it with a solvent and putting it in the machine. All you then understand at that point is what that extract contains. That can be from 1 gram, 10 grams, 100 grams, a kilogram of meat. But it's an homogeneous portion, and it's an average of what's present. With the new technologies, we can actually look at individual parts of the carcass. We can look at the surface. We can look at how these chemicals are incorporated, not only deep within the tissues, but also the contact zones. Maybe that has a different performance in terms of things like fat layers, for example, in poultry. Interesting, it says add picture in my slide there. I've just noticed that. I was going to add a picture, but I hope you've all noticed that. I have added a picture. The reason we haven't added a picture, we don't have the kit on site yet. So when the kit is here, there'll be a lovely picture there of a big blue box, and you'll all be very impressed. It might be a grey box, but it's probably going to be a blue box. But what sort of things can you then couple to the mass spectrometer? One of the things that's been referred to recently is called the iKnife. George Osborne is very excited by the iKnife, so quite clearly it's the way to go. This is a technology which is coming from the medical profession. Originally was developed to differentiate between tumour tissues and healthy tissues in patients instantaneously during surgery. So you have a surgeon's knife, he cuts through the tissue is burned, and the mass spectrometer, the equipment, samples those gases, those burning products, and within a few seconds you can differentiate between different types of tissue being present. And you can think perhaps some applications there in the animal sector as well. Also, there's another application of this technology in terms of looking at microbes, but the one at the bottom with George looking very happy is to do with food fraud and food authenticity, when you can instantly differentiate between different species. But again, it's an evolving technology. It's only been on the go for a few years. It's only been used in the medical profession so far, but that type of advanced technology is being brought into the world of animals. So just to put this into context, what could it be used for? Let's think of the example of product quality. The key thing is to profile your samples, to measure as much data as possible, and often to decide whether the data is typical or atypical, or if it's the same or something has been changing. Hopefully you can see this at the back. Here's some squiggles. I won't ask you to explain what these squiggles are, but each of those lines represents one sample. And each of these humps, these things which look like a mountain range, are the signatures from those samples. And at the bottom, we can measure something which is fairly basic, not changing very much, and we could decide that's normal. But we could then analyse another set of samples which has changes. And those changes could be an atypical effect, or they could be a wanted effect at the end of the day. But this technology will be able to differentiate between those two scenarios. So, as I said already, it's all about product profiling and gaining as much information as possible and answering lots of different questions simultaneously. It could take it another stage. This is exactly the same sort of example, except we've got more samples in place. So it's a helicopter view. And each of these blue lines, these dots, represents information, chemical information regarding a particular sample. And the key thing with this is using informatics, using other tools, is to try to analyse what these individual dots mean within these pictures. And actually the technology will allow us to identify individual chemicals. And those chemicals could certainly be of commercial interest. They might be an interesting co-product. They might be an interest in terms of how the animal's performing. So again, we can then analyse the data in a lot more depth, and that will require the tools of informatics. So putting that all into sort of context, where can we apply mass spectrometry? Where can we apply the iKnife going forward? Well, I think one of the first things is about improved process control, better consistency of products, producing the same thing time and time again. I hear two arguments for that. A lot of the retailers want that consistency. They want the consumer, going back to the consumer again, to have the same product every time they buy it. That's probably the case in the UK. In Italy, they like the variation. They like the fact that their Parmesan cheese is a bit different, for example. So you can use this technology in both ways. You can use it to look at the differences, but also the similarities. The technology can allow you to study many types of chemicals, lipids, proteins, metabolites, anything you're interested in fact. The world is your oyster. But actually, you should regard it as a true discovery tool. Think of the question first, and the technology will provide an answer, hopefully. So anything which involves chemistry, think of a question, and we'll provide some data. And how can that data be used? Well, for me, the One Health agenda, I think, is probably critical going forward. Here at FAIRA, we have the Centre for Crop Health and Protection. crops are used to feed animals. Understanding those crops, the crop health, will then affect what's the animal health is like, especially when you add nutrients to the animal feed. And if you get the animal health right, then hopefully the human health is right. So to be able to follow those processes through using this sort of technology is quite exciting. But there are other issues which can also be studied. Spoilage of products, and also increasing shelf life. And ultimately, by measuring things, you can demonstrate compliance with safety. Consumers always expect that, and obviously with European Union legislation. Finishing and nicking Kim's slide, working together. It is very much about working together, not only between Queen's University of Belfast and Ferro Science Limited. Queen's quite clearly provide some of the blue sky research. Ferro provides very much the applied research in this role, but it's not just about these two organisations, it's working with the other 10 CL organisations to answer some of these big questions. So to me, it's about a multidisciplinary agri-food solution. And my strap line always is, if you can't measure it, you can't manage it. And these type of technologies will be one of those measurement tools. Industry, I think an industry should be driving these centres are all about outputs and outcomes. So for me, if we apply this type of technology, consumers will have safe, consistent products of known quality. For me, industry will be able to reduce their production costs by having better knowledge of how the various feed materials are ending up into the animals. I'm hoping that this type of technology will also identify many more added value products and added value components, and by that I often mean co-products. So when you produce an animal feed, or feed that animal, potentially you'll have what's may be referred to as the fifth quarter, something else which is of value. But at the end of the day, it provides objective correlation between inputs and outputs. And fundamentally, by measuring everything at once, we can have an early identification of change. So there's an element of risk mitigation there and also brand protection at the same time. With that, I'd like to finish. Thank you.
Thank you.
Very
Very good.
Click
Good.
on. And Charlotte's good.
Charlotte, you all right?
And pass over to Charlotte.
Great billing, and then
Seamless.
Charlotte, over to you then.
Seamless. I was here in Ferro for the first time a year ago when this all kicked off, and I think it's brilliant what's been done in that year. I've been on the interim steering board for SEAL, and it's amazing sort of credit to the guys that have worked so hard to get it where it is today, and it's really good to kind of see it all coming together and some of the brilliant things that have kind of been highlighted today. I think I just wanted to sort of say just a few things about customers and how this all sort of ties into kind of the bigger kind of food agenda, really. So customers are continuously changing, the environment in general is sort of changing, and the information that's available to customers is changing as well. And we continually, as a retailer included, need to get more from less. And as a retailer, we have to innovate to sort of remain competitive, but also to keep customers interested. So it's brilliant to hear sort of within the supply chain of the stuff that's going on from an innovation point of view at the farm level, to ensure that the UK industry is able to sort of continually innovate and progress and compete. Customers sort of inherently trust retailers as they go through the door to do the right thing, and a number of things that customers sort of expect us to do would be everything from sort of providing like healthy choices to having safe food, but also things like ensuring that we are working with producers to look out for things like animal welfare, environmental stewardship, and ensuring that they have the best quality products available on the shelves. Everything that I've heard today through some link does have a relationship to the customer, and I think that's sort of really important in the sort of overall food agenda and in general sort of agri-tech mission, which is fantastic. And I think the real thing that, as I said, the sort of landscape about how customers learn about food and the way in which that's communicated to them does change, and that information changes. But what's really important is that we have a strong evidence base to show that we are doing the right thing, be it on nutrition, animal welfare, environmental impacts, and that's something that I feel confident that SEAL is sort of able to deliver, which is brilliant. We've seen sort of examples from things like the beef and sheep CT scanner, through farm networks and sort of environmental things all raised today, which is really brilliant. So I think what I just wanted to say is that I'm pretty excited about SEAL and everything that it offers, and I really look forward to sort of working through it. And in general, I feel that it's the right thing for the agri-industry to have, and it also provides an asset that we can start to really probably tell customers even more about the brilliant industry that we have, and SEAL contributes to the robustness of that, to strengthen trust and just the general overall sustainability of the industry. So yeah, sort of look forward to the next chapter, really.
Great, thanks. That's good. And I think it's so important for SEAL to have that consumer voice, working with it. I know, we put my company hat on. I mean, we're several notches back in the supply chain from the consumer. We often think about, well, how do we get our story across to consumers? And one of the things we sort of always fall back on is that one of the things we do need is credible science from credible scientists. And I think, if SEAL can help do that as well through our supply chain, that's why having post-farm gate with our processor and retailer industry members is really important.